If calculations are very cumbersome, and if a sample size is no more than 5% of the size of the population you are looking at, then you can treat the selections as being independent. This is what we call the 5% guideline, and this is especially nice to be able to use when we are making selections without replacement. So let's just see it in action and see how it makes our lives a little bit easier. Assume that we have a batch of 100,000 pacemakers. This includes 99,950 that are good and 50 that are defective or are bad. If two pacemakers are randomly selected without replacement, find the probability that both pacemakers are good. So we know that we have 100,000 pacemakers in totality, good and bad. And since we are looking for pacemakers that are good, our X value is going to be 99,950. And these are again done without replacement. I'm not going to use the 5% guideline on this one, just again show you what's going on. So the probability of selecting a good one with your first selection, 99,950 over 100,000. Make that 9 look a little bit nicer. Now we've selected one, we're going to put it off to the side, and we're going to select another one. And since we have one less good one, our totality of good pacemakers goes down by 1, and the number of pacemakers in general also goes down by 1. And since we're only selecting 2, we're going to take these two numbers and multiply them together, which is going to give us 0.999. So the probability of selecting two pacemakers that are good, 0.999. Pretty much a certainty that you're going to. Now again, we could have used the 5% guideline, but I wanted to do it for a different reason. When the work is going to be a little bit too cumbersome, a little bit too much to do, like on this one here. This time we're going to select 20 pacemakers, and again, they are without replacement, and we're going to find the probability that all the pacemakers are good. So again, we know we have 100,000 pacemakers to choose from, and 99,950 are good. Now, normally we would do this by starting off with 99,950 over 100,000, and then we're just going to count down from there. So the next one is be 99,949 over 99,999, and then I'm going to select another one, so one less, so 99,948 over 99,998, and so on 17 more times. Now this could take a while and it would be fairly annoying to have to do, or we can do the 5% guideline, which means we need our sample space to be less than 5% of the whole thing. So we're doing 20 pacemakers, so 20. So what we're going to do is we're going to do 20 over 100,000. And when we do that, we're going to get 0.0002, which is definitely less than 0.05 or 5%. So since it is less than, we are good. That means we can treat this event as independent instead of dependent, like what we were trying to do up here. How does that make our life easier? Well, instead of doing each number one less 20 times, what we can do is we can take the total number of good pacemakers divided by the total number of pacemakers. And since we need to do it 20 times, we can just raise it to the 20th power, which makes computation much, much nicer and much, much easier. So doing this, we're going to end up getting 0.990. So the probability of selecting 20 pacemakers that are all good is 0.990. So if you can, using the 5% guideline to treat a dependent event as independent can make all the computations much easier, because I don't think anyone would want to do this out 20 times or even 100 times or whatever. 2 times, like we did here, not too bad.
That can be done very easily. But dealing with 20, 30, 40, 100, that's just too much. So use the guideline. If it's less than 5%, then it's valid and we can just treat it as independent.